Here's page 32 of the notes. Solve a quadratic equation using square roots. So before we talk about square roots, let's calculate squares. If x equals 3, calculate x squared. X squared just means 3 squared in this case. So 3 squared means 3 times 3, which is 9. If x equals negative 3, then I square negative 3 for x squared. That's negative 3 times negative 3, which is also positive 9. Now square roots are the inverse, which means I do the reverse. If x squared equals 9, then x equals, well, if I go backwards, I can say 3, but it could also be negative 3. So one way I can write this is plus or minus 3. I can just write x equals 3 or negative 3 as well. If x squared equals 16, then x equals positive or negative 4. Again, you can write x equals 4 or negative 4. If x squared equals 25, then x equals positive or negative 5. Again, x equals 5 or negative 5. Now, if you have x squared negative, for example, x squared equals negative 1, then there is no real solution. So I'm going to determine the number of real solutions for the following and then solve if there is at least one real solution. A squared equals 10. This is positive, so a equals positive or negative square root of 10. So I can write square root of 10 or negative square root of 10 if you like. Because 10 equals 2 times 5, I cannot simplify these anymore. If b squared equals negative 3, well, that's negative. If a squared value is negative, then there's no real solution. No real solution. For these, I have to do a little bit more work. So at first, I have to move the 15 to the other side, addition, and then I have c squared equals 15. 15 is positive, so I can do positive or negative square root of 15. Now 15 equals 3 times 5. Both are prime, so I cannot simplify this any further. Just square root of 15 or negative square root of 15. Here I need to move the 20 to the other side, so I change the sign to minus 20. And then I have d squared equals negative 20. I have a squared value being negative. That means no real solution. Here you might say no real solution, but first I have to move this 85 to the other side. So I do plus 85. And then I have f squared equals positive 25. That means f equals positive or negative square root of 25, but the square root of 25 is 5. So f equals 5 or negative 5. I'm going to subtract 45 from both sides first, and then I have negative 3r squared equals 0. Then I divide by my negative 3. R squared equals 0. So if I do plus or minus square root of 0, I would see that this is just 0. I have one solution. Here I subtract 144 first. I have 2s squared equals 56. I divide by 2. S squared equals 28. And then I can take the square root. So because s squared is positive, I have two real solutions. And s equals positive or negative square root of 28. 28 equals 4 times 7. So when I do the square root, that is the square root of 4 times the square root of 7. And I can do the square root of 4, that's 2. So this equals 2 square root 7 or negative 2 square root 7. And finally, here I need to add 17 to both sides. I have 5t squared equals 49. I'm going to divide by 5. So t squared equals 49 over 5. It is positive, so I will have two solutions. That means t equals positive or negative square root of 49 over 5. 49 is 7 squared, so square root of 49 is 7, but 5 is prime. So when I take the square root of this, I will have positive or negative 7 over square root of 5. In order to make the denominator rational or no radical, I multiply numerator and denominator by the square root of 5. So that gives me positive or negative 7 square root 5 over, and square root of 5 times square root of 5 just gives 5. So I can write this as 7 square root of 5 over 5, or negative 7 square root of 5 over 5. So to review, if I have a squared term equals positive, I get two solutions, two real solutions. If I have equal to negative, I have no real solution. If I have equal to 0, I have one real solution.